Hey everyone, and welcome to this explainer. I'm absolutely thrilled to have all you developers, data scientists, and AI engineers tuning in today. We're going to be tackling what is honestly one of the most frustrating headaches in modern data science: extracting structured, usable information from raw, messy text, right? If you've ever tried to build a knowledge graph from scratch, you know exactly what I'm talking about. It's a nightmare. But today, we're looking at a pretty groundbreaking approach from an ICML 2026 paper. They've introduced a transparent, glass box pipeline designed to solve exactly this problem.
Okay, let's dive into this, because this is where the real pain actually begins. Think about legacy datasets, or those massive, fast-growing data lakes you're managing, where your unstructured text just has no predefined schema. The traditional approach to ontology design simply cannot keep pace with the sheer volume of data we're generating nowadays. You're left trying to force a square peg into a round hole. Or, let's be real, you're spending your weekend writing endless regex scripts at 2 a.m. just to fix hallucinated structures that don't actually exist.
So here's our roadmap for today. We'll start with the schema induction bottleneck, then enter scope and SCION. After that, we'll look at the auditable SCION pipeline, how we're measuring success, compare SCION Lite versus SCION RL, and finally, wrap up with some actionable takeaways for AI developers.
All right, let's kick things off with Section 1, the schema induction bottleneck.
You see, traditional information extraction is built on this massive, fundamental assumption that you already have your schema beautifully mapped out before you even touch the data. But when we're dealing with vast, unstructured corpora, that assumption breaks down completely. If you just throw a large language model at the problem without a schema, you inevitably end up with hallucinated structures and these awful black box errors that you just can't trace, debug, or trust.
Which brings us to Section 2, Enter Scope and SCION, the dual solution to our problem.
I want to anchor our discussion right now with a single number, 24. This actually represents the massive scale of the new scope benchmark. Scope, by the way, stands for Schema Construction and Ontology Induction Pipeline Evaluation, and it normalizes 24 completely different public information extraction sources to create its foundation. That is a lot of ground to cover.
Now, what's really interesting about this breakdown is that out of those 24 sources, we have 15 relation extraction datasets and 9 event extraction datasets. Scope standardizes all of these wildly diverse sources into a unified typed schema edge representation. It converts them into evaluation-only gold schema graphs. And by doing this, Scope completely removes that cross-dataset variability that usually makes comparing schema induction models so incredibly unreliable.
Moving right along to Section 3, the auditable SCION pipeline. Let's get into some glass box engineering.
You see, SCION isn't just another black box model. It is a meticulously structured reference pipeline. Let's just walk through the exact chronological journey of a piece of raw training text here. First, the pipeline mines candidate spaces directly from the text. That's candidate generation. Then it moves right into naming and merging these concepts. This is followed by strict filtering. Step 4 is validation, and finally, it applies conservative fusion, which optionally combines these newly induced schemas with any existing ontology packages you might have.
Now you might be wondering, how does it keep from hallucinating during all those steps? Well, the secret sauce preventing those hallucinations is JSON contracts. These are strict structural agreements that constrain every single entity, relation, and event output. They absolutely must be backed by linked evidence from the text. This forces schema consistency and makes every single intermediate step we just talked about completely inspectable. No more guessing games.
Speaking directly to the developer experience here, this is exactly why you should care about SCION. Because it's a glass box, it produces an incredible paper trail. We're talking evidence-linked outputs, parse and fallback logs, candidate retention logs, merging logs, and full-run manifests. Think about it. If your fusion accuracy suddenly drops, you don't have to guess why anymore. These logs show you exactly which text spans triggered a bad merge and exactly which validation rules passed or failed. It's honestly an absolute debugger's dream.
All right, Section 4, Measuring Success. We'll be looking at 4 distinct metrics.
And this brilliantly illustrates how Scope evaluates success against the gold standards. These 4 metrics capture completely different aspects of structural alignment. First up, you have literal, which checks for exact node and edge matches. Simple enough. Next is fuzzy. We all know language is messy, right? So this metric accounts for semantic equivalence when naming conventions diverge. Third, we have continuous, which evaluates partial matches and graded similarity. And finally, graph. This one looks at the big picture, assessing the overall structural alignment and the topology of inter-event links.
Let's transition to Section 5, SCION Lite versus SCION RL. It's time to talk about architectural trade-offs.
So, you've got a choice to make based on your infrastructure. On one hand, we have SCION Lite. This variant achieves the absolute highest F1 score across the board, totally beating out LLM-only approaches and Text-2 on-top baselines. But it does rely heavily on higher-capacity proprietary LLMs for candidate space construction. On the other hand, you have SCION RL. This is a much more compact, open model approach. It significantly lowers your infrastructure costs and dependency on commercial APIs. The trade-off? You do take a marginal performance drop on the fuzzy and graph metrics. But hey, if your organization has strict data residency requirements or a really tight budget, SCION RL is a highly viable, cost-effective alternative for sure.
And that brings us to our final part, Section 6, Takeaways for AI Developers. Let's get into some actionable advice.
Now, this is a crucial engineering tip straight from the researchers. When you're integrating this into real-world workflows, remember that SCION is a reference pipeline. It's not some magic drop-in tool. It requires domain-specific adaptation. If you want to boost performance quickly, spend your time adjusting those conservative fusion parameters and checking your merging logs. Doing that will almost always yield faster improvements than trying to entirely retrain your base extraction component.
So the crucial point is this vital quote from the source material. Schema induction is an upstream dependency. Human validation is still required. Yes, this pipeline is state-of-the-art. Yes, it finally opens up the black box. But at the end of the day, schema induction remains a statistical alignment problem. It outputs normalized typed edge targets, but your downstream query engines and automated reasoning systems, they're still going to require human governance. You use SCION to generate an incredibly powerful auditable baseline, but human expertise is still the final validator.
The best part? The tools for reproducibility are all right there in the GitHub repository. The code, the benchmark packages, the run manifests, the whole shebang. The days of blindly trusting a black box LLM to structure your critical data are absolutely coming to an end. So I leave you with this question to chew on. With the black box finally opened by Scope and SCION, how will you apply this transparent logging to audit and improve your own data extraction challenges? Thanks so much for joining me on this explainer today, and happy coding!